Hi all, welcome to switchz.com. Now we'll discuss about the rate of a chemical reaction. What does the reaction rate mean? Normally when we write down the reactants and reactants get converted into products, so what we see with time, we find that the concentration of the reactants decreases and the concentration of the products increase. So with time, the reactants get converted into products. So the concentration here decreases and the concentration of the products increase. Now what does the rate of reaction mean? Rate, as we all are familiar with the processes in which something changes with time, right? Something, when it changes with time, and we express the rate as the ratio of the amount of that particular change in the given time period, right? Or we can say the rate is usually expressed as the ratio of the amount of the change in some quantity to the time required to produce that particular change. Similarly here, a rate of reaction means now what? It means the change in concentration, because here what happens, that the concentration of the reactants here decreases, okay, and the concentration of the products increase here, okay, with time it increases. So we can say a reaction rate is the change in concentration, because with time what happens here, there's a change in concentration, right? Change in concentration, or you can say change in the molar concentration of the chemical species, whether it is the reactant or a product. Okay, so we can define rate of reaction as the change in the molar concentration of the chemical species in the reaction per unit time. Or mathematically we can write down the rate of reaction is the change in concentration divided by the time taken for that particular change. So if you look at the reactions, we find that normally the concentration of the reactants decrease, and if I put plot a graph here, the concentration versus time, you can see this particular graph, it shows the decrease in the concentration, and decrease in concentration is for the reactants. So you can say this is the curve, the concentration curve for the reactants, and the products initially it is 0, right? With time the concentration of product increases. So this is the graph for the products, right? So this is the graphical representation of the concentration of the reactants and the products with time. Okay, now how we write down the rate of reaction? Okay, we can say the rate of reaction means rate of a reaction, you can express it in terms of either reactants or in terms of products, right? So we can say rate of reaction is the change in concentration of the reactants. Suppose here the bracket here means what? This bracket, it represents the concentration of the reactants, and this is the change. And since with time the concentration of the reactants decrease, so I'm going to use the negative sign here, right? So negative sign indicates that the concentration of the reactants decrease. The graph is going down, the concentration of reactants decrease, so I can say negative change in concentration of reactants divided by the change in time, right? The time taken for that particular change. I can also express the rate of reaction in terms of products, right? So I can say rate of a reaction in terms of products can be written as the change in concentration of products, right? So I'm going to write down here the change in concentration of products divided by the time. But since here the concentration of products increase, so therefore I'll use the positive sign. So negative sign here, it indicates that the concentration is decreasing here, while as the positive sign here increasing means that the concentration increase. So we can express the rate of reaction either in terms of reactants or in terms of products. So we only put the negative sign for the reactants and positive sign for the products. So this is the change in concentration of products divided by the change in time, right? So the time taken, the time interval in which this particular change occurs. Now we use terms like instantaneous reaction rate and the average reaction rate. Normally when we talk about the rate of a reaction, it refers to the average rate. Okay, so when we normally use the term rate of a reaction or the reaction rate, it actually refers to the average rate. If you want to find out actually the rate of a reaction, right? Suppose you want to find out during this time interval, right? Suppose this is the time t1 and this is the time t2. During this time interval, what is the rate of a reaction? And that thing you can express in terms of reactants or in terms of products. Suppose at time t1, the concentration of the reactants here is this much, right? Okay, this is the concentration of reactants at the time interval t1, and the concentration of the reactants at time t2, is like this. Now this is the change in concentration, right? This is the change in concentration, and this will be the time interval during which the change occurs. Correct? So if you write down the rate of reaction here, you can say the rate of reaction will be what? This is the change in concentration of the reactants divided by the time delta t, and negative sign because the concentration decreases here. And this is the delta t. So the delta t here is t2 minus t1, right? This is the change in time is t2 minus t1. And the change in concentration will be, this is the concentration, initial concentration, and this will be the final concentration, right, during this time period. Okay, this is the change in concentration of the reactants. We can also express the rate of reaction in terms of products also, right? In terms of products, and say time t1, this is the concentration of the reactants of the products, and at time t2, this is the concentration of the products, right? So in the same time period, the change in concentration of products is, so this will be called as the change, this is the change in concentration of what? Products. You can see the concentration of products increase and the change in concentration of the products during this time period, right? From these two things you can calculate the rate of reaction. Okay, so we can say the rate of reaction will be equal to change in concentration of products divided by the time interval. Normally when you express the rate of reaction between two time intervals, right, it's a average rate. But instantaneous rate of reaction means the rate of reaction at a particular point. Suppose, what is the rate of reaction at this point A? What is the rate of reaction at this point B? So instantaneous reaction rate is basically the reaction rate at a particular instant of time, right? And normally when you calculate, when we want to calculate the instantaneous rate, we actually calculate the rate of reaction for a very small time period, right? For a very small time period. Okay. So therefore we can say the instantaneous rate of reaction will be expressed as small change in concentration of reactants by delta T, right? Or we can also express it in terms of products. So plus sign for the products, small change in the concentration of products divided by the delta T here. So that's the difference between the average rate and the instantaneous rate. The rate the rate measured over a longer time interval is called average rate, while as the rate measured a very small time interval is called as an instantaneous reaction rate. And now what will be the units? What are the units for the reaction rate? As you can see, rate of a reaction is the change in concentration and the time interval, right? So therefore the units will be the units of a concentration and time, right? So we can say units will be, concentration has a units of moles per liter, and time we can say the second inverse. Change in concentration divided by the change in time, so it will be the concentration here, right, divided by the time. Concentration has the units of moles per liter, and time means second here, so it is moles per liter per second. For the gases, for the gaseous reactants, right, and the products for the gaseous systems, we express, concentration in terms of pressures, right? So the units will be the atmospheres, second inverse, right? Atmosphere, second inverse. This is the unit for a gaseous, reaction. Now let's take some examples here. Okay, how do we actually write down the reaction rate? Suppose we got a reaction A plus B, it reacts and forms the C. So I'm going to write down the reaction rate here. So I can say the rate of a reaction will be equal to negative change in concentration of A divided by delta T, right? I can also express it in terms of B. So it will be negative change in concentration of B by delta T. Also express it in terms of C, right? The products. But for the products, we write down the positive sign. Change in concentration of C divided by delta T, right? Now if you have some different coefficients, right, in an equation, suppose like we got A plus twice B, it produces 3 times C, correct? So how do we write down the reaction rate? Now the coefficients are not the same. So you can say here, the rate of a reaction will be equal to same negative change in concentration of A divided by delta T, and in terms of B also you can say negative change in concentration of B divided by delta T, but since here the coefficient is 2, so I'll multiply this one by 1 by 2, 1 by coefficient here. It's because the time period in which 1 mole of A consumes, in the same time period 2 moles of B will be consumed, right? So basically the rate of disappearance of B actually is 2 times for the A, right? So that's why I'm going to multiply by 1 by coefficient, right? To make it for the 1 mole, right? And for here, you can say, the coefficient for A is 1. So if I also write down is 1 by 1, it doesn't, change anything, right? So 1 by 1 is again the same thing. Now for the C, I'll write down the plus, right? Change in concentration of what? Change in concentration of C divided by delta T, and it's what? Time is 1 by 3 here, right? 1 by 3. So this is the rate of a reaction in terms of A, B or C. Now let's take one more example here. Suppose we got a nitrogen, it reacts with a hydrogen gas and it forms ammonia, NH3. Okay, so this is 2 times, this will be the 3 times. Now the reaction rate, how can we express the rate of a reaction here? So we can say the rate of a reaction will be change in concentration of nitrogen divided by delta T. I can also express in terms of hydrogen, but for the hydrogen I'm going to write down 1 by 3, right? Change in concentration of hydrogen by delta T here, and for nitrogen I'll say for the ammonia it will be plus, right, because it is the product. 1 by 2 here because the coefficient here is 2, right? Coefficient is 2, so I'm going to write 1 by 2 change in concentration of ammonia divided by delta T. This is how we write down the reaction rate for any particular reaction in terms of any reactant or in terms of any product. Hope you got the concept. Thanks for watching the video. Bye for now.